Hello guys, welcome to my channel. Today we will discuss about the second normal form. So in our continuation of SQL series, we'll continue with the second normal form. Last video I have covered with the normalization and first normal form. So let's continue with the second normal form. So first of all, what is the second normal form? So second normal form rules are first point is must be in 1NF. So it should satisfy the first normal form, then we can follow the another rules. So here you cannot directly come and transform your data into second normal form. So first you can you must and should be in first normal form should satisfy. So first normal form already we discussed the last video. Okay, so what is the first normal form? So in first normal form, two rules is there. Every column or attribute need to have a single value. Each row should be unique. So this part we had to satisfy. That is the first point in second normal form. Then comes into the second point. I mean second rule. All non-key attributes must be fully dependent on candidate key. All non-key attributes must be fully dependent on candidate key. So here candidate key is what is the candidate key first of all? So generally candidate key is not a constraint as such. It's like a terminology, so used to identify something. So what are the columns? It can be one column or multiple column which uniquely identify a record. So generally, so the candidate key is a set of columns which uniquely identify a record. That is, a table can have multiple candidate keys because there can be multiple set of columns which uniquely identify a record or row in a table. Okay, so this is the candidate key. So in our case, which is the candidate key? So candidate key, for example, in our scenario, first normal form will get the data. So already we have split the data. This is first normal form satisfied. So we'll copy the data same as usual. Copy and paste it here. Okay. So in this data, first normal form should satisfy this one. Okay. So now in this one, what are all the columns? So candidate key we have to identify. So like in our case, which is the candidate key in this example, in this particular example. So candidate key is mainly, if you observe with the candidate key, order number and product code. So for my analysis in this table, order key, order number and product code as the candidate key. Similarly, so if we observe with the, is that any other candidate key? So for example, if you look into this data, order number, quantity, item price, total cost, order date to status. So this complete information is relating to order table. So in our case, for example, let's consider as the order number. So order number is one of the candidate key. Okay. So non-keys are means, so here you can see the definition of non-key columns. So non-key columns are columns which are not part of the candidate key or primary key is non-key columns. So in our case, candidate key, let's assume for order number and product code. So for example, order number is the candidate key. So quantity, item price, total cost, order date, and status are the non-key columns. So why I can say a non-key columns called as columns which are not part of the candidate key or primary key, which are called as the non-key columns. So in this order related information, order number as the candidate key, quantity is fully dependent on order number. So for example, a quantity 30. So this order number is placed the order quantity 30 quantity ordered. item price, total cost. So if you check with the order number, so this related information we will get. Okay. Similarly, if you check with the product code, so product code is any relation with quantity, item price and total cost. There is no way relation. So for example, this product code motorcycles. So in any of the order can replace the replace means again someone is to be placed the order. Okay. For example, here order number 101 is placed with the motorcycles for this particular product code. Okay. How many quantity? 30 quantity. But some X person or Y person or some other order number also again to replace the with order motorcycles. So that is there is no way relation with product code to this table. Okay. Next, so product code is non-key columns are product name, product price. So these two non-key columns are fully functionally dependent on product code. Next, customer name. So customer name also these here there is no customer ID. For right now we'll consider as customer name. So phone number, address line to city, state, postal code, country, territory. So this all information is dependent on the customer name. Next, we look into the sales information. So this sales information is dependent on the order. Okay. So right. Next, let's go back to rule number 2. So what is the rule number 2? All non-key attributes must be fully dependent on candidate key. So here we have identified as the non-key attributes are order number and product code. So let's give the some unique. Okay, so this is I'm giving the color code for this one part for time being. So these two are the candidate keys. So what is the candidate key here in this part? That is, if a non-key column is partially dependent on candidate key, subset of columns forming candidate key, then split them into separate tables. So here in our example, order number and product code as the candidate key. So what is non-key column? Already we discussed. So non-key columns are, for example, quantity is my non-key column. It has to be fully dependent on candidate key. Okay. So for this part too. Okay. Next, for example, if you consider as these all columns like quantity, item, price, total cost, order date, status directly dependent on order number. Okay. So now based on this rule number 2, we will split the data. Okay. So for example, now how I can display order number, copy and split this one is as one table. Okay. And product code. So this product code, product name, product price as split into another table like product table. Next, customer name. For example, here customer name up to territory, copy and split into this part. Okay. Next, sales information. But sales information is relating to depends on the order table only. So let's continue with this part, or else we will remove this part. Let's move this one, and this sales information also will copy into here. Okay. Just a little bit zoom. Now, if you look into quantity, so I think this information also not needed. We will remove this part. Yeah. Now you can see the split into the how many tables. I can split that this information into 3 tables total. So first one, order number. So quantity, item price, total cost, order date, status is fully functionally dependent on order number, and sales information also fully functionally dependent on order number. Next, product name, product price dependent on product code. Next, customer details. So this all information will dependent on customer name. Okay. So up to this one is splitting is fine. So after splitting, here one problem here. So what is the problem here means basically there is a duplicate data. So how you can apply with the how you can see the duplicate data and to apply with the third rule. Okay, so this is up to second rule I have seen. Now I can apply with the third rule. So every table should have primary key and relationship between the tables should be formed using foreign key. So now here I can apply with the relationship should have primary key and relationship also. So relationship means we'll use with the foreign key. So based on the foreign key, we will give as the relationship. Okay. So before giving the relationship, let's check with the primary key first. For example, in this table, if I consider this order table, this is the primary key. Let's give the primary key. Okay. And product code also primary key. So primary key, if I give the order number as the primary key is it's not allow the duplicate values, means unique and not null. But in this order number, if you look into this, two duplicate values. So 101, 101, 06 as the duplicate row is there. So we had to eliminate this duplicate rows and assign as the primary key. So here one option, relationship first will create one more column, or else this one order number will give as the primary key. So if we give order number as the primary key, we will replace the value to duplicate value. For example, this 106 to 107 and will identify as this one, some color we can give, okay, yellow, or else bold. Okay, so yellow color, bold I have given. Because of this column is mentioned as the primary key. Next, in product code, similarly, you can check with the duplicate values. So if you check with the in this product code 104, 105, 1004, 1005, so duplicate values is there. So let's remove the duplicate values. So here, for time being, I am removing these values into Excel sheet only. So data, under the data, we will remove the duplicates. Remove duplicates, click on OK. So here two duplicate values found and are removed. Okay, fine. So two duplicate values are removed. Next, so in this part, there is no unique ID is there. So customer name we can't give as the primary key. So let's create one more column as ID. So for example, this part will move to here, and here I will give as the column name ID, customer ID. So customer ID, let's give as 1, 2, 3, 4, 5, 6, 2, 3, 4, 6. Auto canal petit. So here also some duplicate rows is there. So let's remove this duplicate rows in this table also for time being. Here we'll go and remove, click OK. So one duplicate row, fine. So that is duplicate rows removed. Okay, so this is normalization done. So up to second step is done. Okay, rule number 2 is done, and duplicate values also removed. Now we have assigned as the primary key also done. So customer ID, this part as will give you all borders. Okay. So now customer ID is 1, 2, 3, 4, 5, 6 done. So now this has the primary key. Okay. Up to this one is fine. Now the data looks fine. Okay. So here Third rule is third rule. What he is saying, every table should have a primary key. So order number primary key, product code primary key. Okay, already given here, and customer ID primary key is given. Next thing, and relationship between the tables should be formed using foreign key. So how we'll assign the relationship? So relationship also will give us two ways. For example, so this sales information is there. We'll remove this part. Okay, territory. Okay, let's do format this part. Okay, now so relationship how will give us. For example, this uh, order table. So order table relation to product code and customer ID. So how will give us a relationship? So here again, you can create with product code and customer ID. So this way you can create with two columns and assign the relationship, or else you will create with one more table. So that is fourth table we will create and assign the relationship. So for time being, I will use with new table. So new table called as I'll assign as order number and product code, customer ID. Okay. So order numbers I know. So already order numbers are, so these let's consider as these order numbers, unique numbers, order number. Okay. And product code. So product code in first normal form already we have done with the denormalized text. So this part product code, I'll consider this one. This product code and customer ID, let's consider these values 1, 2, 3, 4, 5, 6. And this one also 6 will give. Okay, so here why I am giving the 6 call as there is no customer ID. So for time being, I'm giving a 6. Okay, next, how will now I have created the table that is order number, product code, customer ID. Now we have to build the relationship to these three tables. So here this is the primary key. Now we'll create the foreign key. So foreign key where we have to create either in the parent table or child table. Okay. So for example, in our analysis, uh, for example, if any company is to establish any or to invent or to create any new product. For example, so let's consider as the mobiles. For example, XYZ companies started the business, another products other than this these products, they started with the mobiles also. So again, you had to add this product into a product table and here also. But if you add here, you have to add order number and customer ID also. But there is no orders yet. So just a product is launched. So, but there is no orders. So in that case, here we can't add. So in this case, if you add a product here, there is no choice. So let's consider this as the foreign key. So if you add master tables, let's assume this one as the master table. So in the master table, if you add the product, then that is fine. Directly, if you add with the child table, so it can't allow. So first master table only will allow. So then in that case, we will create the foreign key as this one also foreign key, and this one also foreign key. Okay, and this one primary key also, primary key comma foreign key. Okay, order number. So this is unique number only, right? Order number. So now order number, primary key and foreign key will create foreign key relationship given, product code foreign key relationship, and customer ID also foreign key relationship. Okay. So now here order number is relating to this part. Now, if we add any product, directly we'll add here mobiles. If any new order placed, then we'll add orders. After that, we'll add here. So that is fine, master table and child. So now this one has the child table, and these three are the master tables: order number, product code, and customer ID. Okay. So this is the way we'll create as the will what we say will partition the tables. Okay. So generally the normal form is splitting the tables into smaller. So the smaller tables is depends on our requirements. There is no hard rules. Okay. So exactly you should do this, or there is a lot of what do you say? There is a lot of permutations and combinations. So you can assume. Okay. So you can do normalization many different ways. So exactly, for example, someone has some company, the same information we have split it as into three tables and one relationship given. Some X company is split this table into 4 to 5 tables also. If you do with the normal form normalization up to fourth normal form, fifth normal form, the same tables will split into smaller chunks. So if you do smaller chunks, also one of the drawback is when you are joining with the tables, so it's very complexity. Okay, that is the reason. So we have to split the data as much as possible, but good way. So good way called as mainly already we have to given the definition, right? Effectively designing a relation database. So that way only we have to design this one. So there is no hard rules for any normalization form, any specific uh, table. Okay. So just overview how whatever we have discussed right now. So basically I have discussed it as first, second normal form. So second normal form conditions are three rules. First rule as must be in first normal form. Second one, all non-key attributes must be fully dependent on candidate key. So candidate key already given example. So candidate key means set of columns which uniquely identify. Okay. And non-key columns. So non-key columns are columns which are not part of the candidate key or primary key. Next, what is this partial dependency also given here definition? So partially dependency means if your candidate key is combination of two columns or multiple columns. So multiple columns means here one thing here in our first normal form we have identified as the candidate key, order number, and product code, right? So we have identified only these two columns. Okay. Another multiple columns also we have to identify. So for example, order number and product name also will consider as candidate key. But in this case, product name, why we are not considering called as, generally we are identifying the keys as any IDs. So names we can't prefer the keys like candidate keys. So that is the reason we have preferred as product code and order number as the candidate key. Next. So once we have how we have split the data. So based on after identifying the candidate keys, so based on the candidate keys, we have split the data. So that how we can split the data based on second rule. All non-key attributes must be fully dependent on candidate key. So must be fully dependent means, so those non-key columns must be fully dependent on key column. Key column is candidate key. So after splitting the data, then we can give the relationship. That is third point. So every table should have primary key and relationship between the tables should be formed using foreign key. So relationship how we have created either. So relationship also will give us multiple ways, but based on our convenience. So for example, here you can create with one more column as product code and customer ID, and you can give the relationship. That is one choice, or else you can create with new table freshly and assign as the relationship. So this is some example of second normal form, how it is working the second normal form. Okay, so I will share this complete Excel sheet through Google Drive. You can check this Excel sheet. Okay, so first normal form also the same Excel sheet only. Third normal form also the same Excel sheet. Complete information is available. So complete normalization, first normal form, second normal form, third normal form, and anomalies also covered in this part only. Okay, anomalies means in this Excel sheet is covered. I will do another video for part 3, third normal form, and insertion anomalies, deletion anomalies, update anomalies I will do. Okay, so let's check in this complete Excel sheet. In the description, I will give the link as the Google Drive link. So in Google Drive, how I can place it with here are not mentioned. Go open the Google Drive. Okay, so in Google Drive, I have pasted this Excel sheet and supported files. Complete supported files is available in the Google Drive. So please check. Thank you. Thank you for watching. Thank you for watching. Please like and subscribe if you like the content.